In this video, we're going to look at CC1, states of matter, and the information for this topic can be found on page 2 of your Combined Science Chemistry Paper 1 guide. This topic only comes up on paper 1, and there's only 4 real things that you need to know. In this video, we're just going to focus on the top 2. Point 1 is describe the arrangement, movement, and relative energy of particles in solids, liquids, and gases. And that information is summarized in this table. So when we're talking about states of matter, we're talking about solid, liquid, gas. They are your 3 states of matter. And if you look at the particle diagrams down at the bottom, you can see how the particles are arranged. In a solid, those particles are very close together and they're arranged in a regular pattern. Okay, nice, neat rows, we call that a regular pattern. In a liquid, those particles are still close. They are still touching each other, but instead of being in nice, neat rows, they are now randomly arranged. We describe this as randomly arranged. In a gas, those particles are no longer touching. They are now spread far apart, and again, they are randomly arranged. In terms of the movement of particles, in a solid, those particles, because they're so tightly packed, they can't move freely, and instead, they just vibrate around a fixed position. Okay, so they vibrate in a fixed position, meaning they don't move from their position, they just vibrate. In a liquid, those particles can move around each other. They can't just move freely wherever they want. They are restricted by the fact that they're still in contact, but they can move around each other. In a gas, because the particles are so spread out, there's no restrictions on their movement, and they can move quickly in all directions. If we look at the energy of the particles, the gas particles, which are the ones that can move quickest, they're the ones that have the most energy. The solid particles, the ones that can only vibrate, they're the ones that are lowest in energy. If you want to go from a solid to a liquid to a gas, this is called state changes. Okay, so you're changing your state of matter, it's called a state change. And to go from a solid to a liquid, the name of the state change is melting. To go from a liquid to a gas, the name of the state change is evaporating or boiling. To go from a gas back to a liquid, that is called condensing. To go from a liquid to a solid, that is called freezing or solidifying, although freezing is more common. If you want to go from a solid to a liquid, the particles are becoming further apart. If you want to go from a liquid to the gas, the particles you can see are really far apart. The particles in a solid, they're attracted to each other. If I want to go from a solid to a liquid, I need to break the attraction. If I want to go from a liquid to a gas, then I really need to break that attraction so that the particles are spread out. In order to break that attraction, you need to put energy in. And we put energy in the form of heat. So you would know that if you wanted to melt ice, you would need to warm it up. If you want to boil water, again, you would need to heat it up. And the reason you need to put that heat energy in is because you need to overcome the attraction between the particles so that the particles can move further away from each other. And obviously going from a liquid to a gas, they're moving really far away from each other, so you need to properly break down those attractions. If I want to go the other way, okay, the particles in a gas, they're moving quickly in all directions. They're nowhere near each other. I need the particles in a gas to become closer together so that I can form a liquid. And in order to do that, you cool it down. When you cool a gas down, the particles move a lot slower. And when they move a lot slower, they start to come together. If you want to go from a liquid back to a solid, again, you're going to cool it further. Because if you cool it even further, you're slowing them right down. That allows the attractions between the particles to build back up again, and they will form a regular arrangement. So to go this way, you're heating, so you're adding heat energy. And then to go the other way, you're cooling, you are removing heat energy. So you're adding energy. And then to go back the other way, you are removing that heat energy so that the particles slow down, move closer together, and then eventually form that fixed arrangement. Okay, we're going to look at some worked examples of typical questions you might find on this topic. They are on the top of page 3. You're going to get lots of kind of 1-mark questions on this, and we'll practice a few of those in a minute. But there are a few slightly longer questions that you can be asked, okay? So the first one here, describe in terms of particles what happens when a solid is melted, okay? So if you want to melt a solid, you need to break the attraction between those particles so that the particles are slightly further apart as they are in a liquid. Okay, to do that, those particles will need to gain energy. Once they gain energy, the attraction between them will be overcome and the particles can move further away from each other. Particles no longer have a regular pattern, so they had a regular pattern as a solid, and now as a liquid, they're randomly arranged. And then in terms of the movement, as a solid, they were only able to vibrate, but as a liquid, they can now move around each other. Okay, so in terms of particles, if you go from a solid to a liquid, you're going to change the arrangement of the particles, you're going to change the movement of the particles. And this all happens when the particles gain energy. Similar type of question, what happens to the particles when a gas is condensed? So if you're condensing a gas, you're removing that heat energy. You want the particles to slow down and move closer together. Okay, so the particles are losing energy, the particles are slowing down, they move closer together so that they're now touching. Remember, in a gas, the particles were far apart. In a liquid, those particles are touching. And in terms of the movement, in a gas, they could move quickly in all directions, but in a liquid, they're just able to move around each other. Question 3, explain why state changes are physical changes and not chemical changes. And I'm just going to jot down here on the side the difference between a physical change and a chemical change. In a chemical change, when a chemical reaction takes place, you get a new substance. In a physical change, you get no new substance. Chemical changes, so chemical reactions, they are hard to reverse. So it's hard to go back after a chemical reaction, but a physical change is easy to reverse. Okay, and this question asks you why state changes are physical changes. Well, if we look at your state change, if we use water as an example, if I go from ice to liquid water, okay, all I'm doing is rearranging the particles. The formula of ice would be H2O. The formula of liquid water would be H2O. I'm not making anything new. All I'm doing is rearranging those H2O molecules, so no new substance is formed. The other criteria was it easy or hard to reverse? If I melt water to become a liquid, I can easily then pop that water back in the freezer and turn it into ice again. So it's really, really easy to reverse that change, okay? So because of that, we say that state changes are physical changes. You're not making a new substance, you're just rearranging the particles, and that change is easy to reverse. To test yourself on what we've looked at so far, go to page 4 of your booklet. There are a few practice questions. Section A are all short one-word answers. Have a go at just doing questions 1 to 10. Section B is slightly longer. Have a go at doing questions 1 to 5. Pause this video, have a go, and press play when you're ready to see the answers. So we'll run through the answers. Section A was hopefully straightforward. You should have solid, liquid, and gas for question 1, solid for question 2, gas for 3, gas for 4, solid for 5, physical for 6, evaporating for 7, or boiling, melting for 8, condensing for 9, freezing or solidifying for 10. You could also write condensation instead of condensing and evaporation instead of evaporating. If we move down to section B, question 1 asks you to describe how particles are arranged in a solid. This is for 2 marks. You get 1 mark for saying tightly packed or very close together, and you get your 2nd mark for saying in a regular pattern. For 2, the movement of particles in a solid, you'll get 1 mark for saying vibrate and your 2nd mark for saying around fixed positions. For 3, you're going to go back up and use worked example 1 that asks you to describe, in terms of particles, what happened when a liquid boils. And similar to my example in number 1, if you're boiling a liquid, then the particles are going to gain energy. You're going to overcome the attraction between the particles and the particles will move far away from each other. So you're going from a liquid to a gas. They need to gain energy and move further away from each other. Once this happens, the particles will no longer, once this happens, you've made a gas instead of a liquid, the particles are now further apart, okay, and randomly arranged. Remember, in a liquid, they're still touching each other. As a gas, they're no longer touching, so they're far apart, they're still randomly arranged. And in terms of the movement, as a gas, they can now move quickly in all directions, whereas as a liquid, they could only move around each other. 4, I asked you to describe what happens when a liquid freezes. So you're going to use work example 2. When you're freezing a liquid, the particles will lose energy and slow down. They'll move closer together so that they're now in a fixed pattern and a regular arrangement. The particles can no longer move around each other. The particles can now only vibrate. So if you're going from a liquid to a solid, describe the change in arrangement, describe the change in movement, and tell me the particles are losing energy and they are slowing down. The last question there, number 5, is exactly the same as worked example 3, and that is how you would answer it. There's also exam questions at the bottom of page 4. Just pause and just do question 1 because that's all that we've covered. Just do question 1 and then press play when you're ready to see the answers. Okay, so the first one should be straightforward. This diagram represents a liquid. This is a solid. This is a gas. If you leave a liquid in a warm room, eventually it will evaporate. The process would be evaporation. You're not going to get a mark for boiling there, okay? Water doesn't boil until 100 degrees Celsius and the room doesn't reach that temperature, so you're going to write evaporation. The freezing point of water is 0. If you cool water from 10 to -10, they want you to describe what happens to the movement and the arrangement of the particles. If you're going from 10 to -10, you're going to freeze water. So how does that affect the movement? Well, as a solid, the particles can only vibrate. And how does that affect the arrangement? As a solid, the particles are tightly packed in a regular pattern. This is only for 2 marks, so you don't need to expand any further than that. Okay, that's all for this video. We will come back to this topic in the next video and we'll go through the last 2 points.